Hello students. As we know, the regression line is the main concept in statistics, and in previous video we have seen that the very fundamental concept of regression line, that is its philosophy. Now we are going to derive its equation as a line, that means the straight line of regression line. Okay, so that's the derivation of the equation of regression line in this video. Okay, so till so far we know that the regression line can be obtained for any multivariate distribution. So if there is the regression curve in terms of regression line, then we get the regression line, that means particularly straight line. If there is a regression curve like that, the parabola, then we get the quadratic equation. If the regression curve is the cubic, then we get the cubic, and etc etc. Okay, so here we assume the first state, that's the regression line, that means the straight line. Okay, so what we see here, the equation of the straight line, as we know in since our previous classes, that is from junior classes, that's the equation of a straight line in terms of y is equal to a plus bx. You may assume it y is equal to ax plus b also. It doesn't matter. So y is equal to a plus bx is a curve of the best fit for a given bivariate data distribution. Okay, and a and b are the constants here. So if we take it the summation on both sides, then what we get, the summation of y is equal to na plus b into summation of x. So what we see here, that's if there are many y's and many x, the number of x is already equal to the number of y's. Okay, because in a distribution we have already the values, the total number of x and total number of y always same. Okay, so let it is n, that means the n values of x and y, then if you take the summation, then summation of y, and a repeats n times. Okay, so why it is n a here. Okay, okay, then if we multiply both sides by x, then what we get, the summation of xy is equal to uh, a into summation of x plus b into summation of x square. Why there is na is changed to a into summation of x? Because there are na, that means separately if you write a plus a plus a plus a plus a n times. Okay, and then we multiply each of a by x, so then we get the a into summation of x. Okay, so then if we divide it by n, that means the first equation, if we take the first equation is y is equal to a plus bx, second equation is summation of y is equal to na plus b summation of x, and third equation is xy summation is equal to a summation of x plus b summation of x square. So if you see here by the equation of 2, that means the second equation, that means the summation of y by n is equal to n a by n plus b summation of x by n, that means we divide it by n. Okay, the equation first. Okay, then what we get, summation of y by n is equal to mean of y, and in RHS there is a plus b into summation of x by n, so that is the mean of x series. Okay, so what we get finally, we get the equation y bar is equal to a plus b into x bar. So see here carefully, that's what we have, the fundamental equation of this straight line, that means the regression line is equal to y is equal to a plus bx, which we assumed previously, and here we see y bar is equal to a plus bx bar. So that means it is clear that the points x bar comma y bar lies on the line y is equal to a plus bx. So that means we see the coordinate point, the point which coordinates are the mean of x series and the mean of y series always lie on the regression line. One thing we note here. Okay, so that means obviously x bar comma y bar lies on the regression line always. Now we shift the origin. Oh, oh, 1 second. Now we shift the origin to the point x bar comma y bar. Therefore, what we get, the equation number 3. What do we get? The equation number 3 is here. Summation of xy is equal to a summation of x plus b summation of x square. So that will be changed in summation. In place of x we write x minus x bar, in place of y we write y minus y bar is equal to a into x minus x bar plus b into x minus x bar square. Okay, so now we simplify this. That means according to previous video we write it here, x minus x bar is capital X, y minus y bar is capital Y is equal to, what is this, a into summation of x minus x bar. So what's this? This is 0. Okay, this is 0 always. I think you all students know this. Why this is 0? Because the deviation of all the values from its mean is equal to 0. Okay, and what is the value of r? So value of r is equal to summation of capital xy by n into summation of n into sigma x into sigma y, which we have derived in previous video, when we have derived the equation of correlation coefficient. Okay, so there is, so r is equal to this, so y, that's why the summation of capital xy is equal to r into n into sigma x into sigma y. Okay, so we replace here summation of xy is equal to this, r into n into sigma x sigma y is equal to, there is b into the summation of capital X square. So what is this? We know the standard deviation, the value of standard deviation summation of x is equal to square root of summation of x square by n. So if we squaring on both sides, then we get the sigma x square is equal to summation of x square by n. So y, the summation of x square is equal to n into sigma x square. Okay, so finally we get b is equal to r into sigma y by sigma x, and that is known as the regression coefficient of y over x. Okay, once again I repeat, so that is known as, that means this value r into sigma y by sigma x is known as the regression coefficient of y on x. Okay, so we replace the value of b in our first equation, very first equation, y is equal to a plus bx. So we replace the value of b here, so y is equal to this, and y bar is equal to a plus r into sigma y by sigma x into x bar. Okay, so what we get finally, we just subtract these two equations, that means this and this, and then we get y minus y bar is equal to r into sigma y by sigma x into x minus x bar. This is the regression line. This is the equation of regression line of y on x. Similarly, we can find the value. Similarly, we can find the equation of the regression line of x on y. That means we will get in that equation the x in place of y and y in place of x. So that's the equation we can find similarly. Okay, so that's the equation of regression line. This is known as the regression line of x on y and regression line of y on x. Okay.